All right, quiet down, please. So today, our goals are to identify extrema. What word do you hear in extrema? Extreme, right. So these are the extreme values. So extrema are extreme values. Those are the extreme highs and lows. We're also going to talk about end behavior. The end behavior of a function is important because we always look at this interesting part of the graph in the middle, but most of the graph, most of the function is what happens at the ends of the function. So end behavior is very important. We're going to start with some vocabulary, then we'll talk about extrema, and then end behavior. All right, turning points are literally the points where the graph turns. So if you look at this, you can see the turning points. How many turning points on the first graph? Look at the graph. How many turning points? You guys see 5? 1, 2, 3, 4, 5. Yeah, so they're the points where the graph turns. I'm going to write mathematically the point where the graph changes between increasing and decreasing. So it's decreasing, then it's increasing, that's a turning point. It's increasing, then it's decreasing, that's a turning point. Okay, so the turning points are where we change between increasing and decreasing. The absolute maximum on the graph is going to be the point that has the largest y value in the whole graph.
Why would I do that? But no, I would never.
All right, actually, sorry. It's not the whole point. It's just the largest y value, which means the absolute minimum would be the smallest y value.
Wait, so for absolute maximum, I shouldn't write the point that has the largest.
Yeah, because it's located at that point, but we want to indicate the y value, not the x value. Understand. A relative maximum has a smaller y on each side. And a relative minimum has a larger y on each side.
Each side of like what?
Each side of the point. Okay, one thing that you should know is that maximums and minimums will never be infinity. Which seems weird, right? Because infinity is the biggest number. Never negative infinity or infinity. Okay, so going back to the picture, you can see the lowest point on the whole graph is your absolute minimum. But you also have two relative minimum. And the reason these are relative minimum is because you have a larger y value on both sides. You see that? You have a larger y on the left and a larger y on the right. This graph has no absolute maximum because it goes to infinity. When it goes to infinity, it has no absolute maximum. All right, in the box here it says the plural of maximum is maxima, the plural of minimum is minima, and such references fall under the category of extrema. So if I just asked you to find extrema, then you would be counting all the maxima and minima. We're going to do the first graph together, and then you guys are going to work on the second graph.
So if it's any of those, we
Sometimes it's more than one. Yeah, like this graph has a lot of turns, so there's probably going to be more than one. Okay, absolute maximum. What is the largest y value on the whole graph? 65, good. 65 is the largest y value on the whole graph. So I'm going to write this way. Y equals 65. That's the largest y value. Sometimes a question will only ask you to identify that. So sometimes you're done. However, sometimes they're going to ask you to tell you the location at x equals 7. Okay? Oh, that's really hard to see. But I did want to write it different because I want you to know that sometimes they just want 65. And then sometimes they want you to tell them where it is located. So it's at x equals 7. All right, so Bang suggests negative 14 is the lowest point on the whole graph. Anybody agree? One person agrees? Anybody on that side of the room? Yeah? 3, 4 people agree? Yes. Y equals negative 14. And then I'm going to write the location at x equals what? 1. Good. All right, does this graph have a relative maximum? A relative maximum looks like a mountaintop, but it's just not the highest point on the whole graph. Do you guys see one? Yeah, I see one right here, and it's kind of hard to read, but I'm just going to see if I can draw something to help me read it. That's the location, but that's not my answer. Do you guys think it's about 40? Does that sound right? Okay, so we're going to say y equals 40. And then the location will be at x equals 4.
So the relative maximum isn't the highest point on the graph.
No, it just has to have points that are lower than it on its left and its right. And then it looks like a mountaintop. A relative maximum will look like a mountaintop. Sometimes it can be both a relative maximum and an absolute maximum, but not in this case because we had a different absolute maximum. Yes. So the relative minimum does not have to be the lowest point on the graph. It's going to be like a dip. Do you see a dip besides the absolute minimum?
Would that be at 6 and 10?
Yeah, it looks like it. All right, so it looks like you're going to have a relative minimum of y equals 10 at x equals 6. Okay, so take a note. Y equals negative 14 is actually both an absolute and a relative minimum.
Is that
It's the lowest thing on the whole graph, but it also has points that are higher than it on both sides. Just so you're not confused, because sometimes they'll say you can just count it as absolute, and sometimes they also want you to count it as relative. However, this point on the end, this is not also a relative maximum because it doesn't have any points on its right.
this is just for this graph?
So I'm going to ask you guys next to try to identify all the maxima and minima on this graph on the right. All right, so remember I told you that the answer will never be infinity or negative infinity. So for the absolute maximum, since it goes all the way up to infinity, we're not listing this one as absolute maximum because it keeps going up. You write none. The absolute maximum, the highest this goes is actually to infinity. It goes higher than this point right here.
But what if that is, never mind.
So you never write negative infinity or infinity as an answer because we can't get to that. So when it goes to infinity, you're going to write none. Absolute minimum, what is your lowest y value? Negative 4, good. So y equals negative 4 is your absolute minimum. And then the location, I've lost my pencil, I found it, is at x equals negative 8. All right, relative maximum. Now that we know this is not an absolute maximum, it's a relative. So how many relative maxima do we have? 2, yeah, we have 2 mountaintops. So we have y equals 6 at x equals negative 2. And we have y equals 10 at x equals 2. Okay, so we had 2 relative maxima. How many relative minima do you guys see? So listen, we know this is an absolute maximum, right? Remember that it's also a relative minimum, so that on Delta Math, if it asks you how many relative minima do you see, you would see 1, 2, 3, okay? However, for our purposes, we already listed it as an absolute minimum, so we're not going to list it again. We're going to say y equals 0, and the y equals 0 is at 2 different locations. Y equals 0 at x equals 0, and y equals 0 at x equals what? 5, yeah. So y equals 0 at x equals 0 and x equals 5. Okay, so y equals 0 is our relative minimum. Now, if you also wrote y equals negative 8, you're not wrong. I'm just saying you don't have to write it again for my purposes, okay? All right, questions on maxima and minima? All right, let's turn the page. Yes? So I've got 2 ahead of you, and you'll be 3rd. All right, end behavior. We're on the back. End behavior of a function describes the trend of the graph if we look to the right end of the x-axis as x approaches positive infinity, and the left end as x approaches negative infinity. So basically, we're just trying to figure out, on the left side, is the graph going up or down? And on the right side, is the graph going up or down? Sometimes people find the notation confusing. So as x goes to negative infinity, that's talking about the left side. As x goes to negative infinity, what is the y going to? It's going down. What's that? Is down positive or negative? Negative. So it's going to negative infinity. As x goes to positive infinity, that's the right side. The y is going to, it's going up, so what's it going to? Positive infinity. All right, and so this is saying the same thing. This is just reading it out to you. The arrow means approaches. So as x approaches negative infinity, the y value is approaching negative infinity, because we can't actually get to it. As x approaches positive infinity, the y value is also approaching positive infinity. That's what the arrow means, is approaching. All right, we're actually going to do this one together, and then you guys are going to work on this one. I'm going to have you label your axes on the x-axis, negative infinity and positive infinity. And then on the on the y-axis, negative infinity and positive infinity. Okay, domain. Your domain starts all the way over here on the left. This arrow, even though it's going down, it's also going left. And it continues until all the way on the right. So your domain is negative infinity to what? I heard one vote over here on that side of the room. Negative infinity to what? Positive infinity. Okay, your range starts at the bottom. These arrows are pointing down to what? Negative infinity. Does it keep going all the way up to positive infinity? No, it stops at what's, we're going to say that it reaches this one. We're just going to estimate. So what's that largest y value? Can you guys find it? About 5. 1, 2, 3, 4, 5. I'm getting 5. I get that it wasn't exactly that. I was just rounding it. I'm including it. All right, for increasing and decreasing, let's draw. Remember how we connect your turning points to the x-axis? By drawing these dashed lines to connect to the x-axis, we can focus on these numbers. 1, 2, -3, +1, and +3. Okay, we're going to read it from the left to the right. Is this first part increasing or decreasing? Increasing. Then decreasing. Then increasing. And then finally decreasing. All right. Now we're just going to look at the x-axis. Remember, increasing and decreasing is only x numbers. So on the x-axis, it's increasing from negative infinity to -3. Always use parentheses on increasing and decreasing. Decreasing from -3 to 1. Increasing from 1 to 3. And then decreasing from 3 to positive infinity. Because remember, it's the x number that matters, not the y. So 3 to positive infinity. All right, there's not a lot of room here. So remember how I told you the y value is the important part of the extrema? We're just going to identify the y values here. Absolute maximum, what is the highest y value on the whole graph? You guys remember that number? It was 5, right? So your absolute maximum is 5. Relative maximum is going to be the other mountaintop. What's the y value of that? 3 is right, yeah. Okay, for the relative minimum, we're looking for that dip, but remember we need the y value, not the x value. What's the y value? 0. It is 0, good. And then why did I not write absolute minimum? Yeah, because it's going down to negative infinity. So don't write the absolute minimum. Okay, end behavior. As x goes to negative infinity, that's the left side. As x goes to negative infinity, what is the y going to? Positive or negative? Negative infinity. As x goes to positive infinity, that's the right side. And then y is going to negative infinity. Well done. Because it's going down. Okay. All right. Okay. All right, domain. Starts over here at the left and continues to the right. Okay, give me a thumbs up if you got that. Negative infinity to infinity. Who got that? All right, good job. Who has a question? Go ahead. That's not a question. That's a very helpful statement. Thank you. All right, negative infinity to infinity. Good. All right, range. this one is pointing down to negative infinity, but here's what I saw from a lot of you. You said, okay, negative infinity up until 5, but we forgot that the graph does continue and goes all the way up to what? Positive infinity, yeah. So you can write infinity or positive infinity. Either one's fine. Here. All right, for your intervals, it does help to connect your turning points to the x-axis and to write those numbers so that you make sure you're using those x numbers for increasing and decreasing. 1, 2, 3, 4. So -4, -2.5. If you estimated that differently, that's okay with me. 0 and 3. So I'm looking at those x numbers for increasing and decreasing. Okay, so we start by decreasing. We're decreasing from negative infinity to -4. Then we're increasing -4 to -2.5. Decreasing -2.5 to 0. Increasing 0 to 3. And then decreasing 3 to positive infinity. Okay, so you had 2 increasing intervals and 3 decreasing intervals. All of them should be using the x values, and by labeling the x values on the x-axis, it helps you notice those numbers. Take a minute and let me know what questions you have on that. Yeah. Okay, good question. The question is, should we use the square bracket? The easy answer is, for increasing and decreasing, just remember we always use parentheses and we never include the endpoints for increasing and decreasing. Other questions? All right, extrema. Why are there no absolute maxima or minima on this graph? Because it goes to positive infinity and it goes to negative infinity. So no absolute. There's only relative. So I have relative maxima. And there's going to be 1 at 1, 2, 3, 4. Remember, we're looking at the y values. Y equals 4. And then the other one is at y equals what? Remember to look at the y value. The y value, I think, is 5. And then we have, I think, 2 relative minima. This one and this one. So y equals 2. And where is the other one? Y equals, what's the y value of this? It is -2. Good. All right, notice they didn't write any of the end behavior for you. The left part of the end behavior, this part up here, it always starts the same. We're just talking about the left side and the right side. So you can always set that up for yourself if it's not there. As x goes to negative infinity, as x goes to positive infinity. We want to know, what does the y go to? Okay, so I haven't answered the question at all yet. That's just like the framework for the answer. I'm going to pause there because if you didn't have that yet, maybe you know how to fill it in now. As x goes to negative infinity is talking about the left side. As x goes to positive infinity is talking about the right side. Okay, so on the left side, as x goes to negative infinity, my y is going up, so it's going to what? Positive infinity, good. On the right side, as x goes to positive infinity, my y is going to negative